assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
30.74. So if you put water near some intense neutron source, the neutrons can collide with the water molecules and sort of, slow down enough that they get captured by some of the hydrogen nuclei to form what's called deuterium, which is just hydrogen with one neutron in its nucleus instead of a proton by itself. And this gives off a gamma ray. And so we want to find the energy of that gamma ray. So if we imagine that all of the initial kinetic energies are small, and we're told that the neutrons are getting slowed down to almost zero speed, and compared to this sort of thing, whatever sort of thermal motion the nuclei and the water molecules have is not going to be too terribly relevant for us. So our Q value then is going to be just the usual story here. We're going to have c squared and then the change or the difference in mass between the final and initial states, or in this case between the initial and final states, because it's an extra energy that gets kicked out. So we'll have mass of hydrogen 1 plus the mass of our neutron minus the mass of our deuterium. And so these are all numbers you can look up. And so we get 2.224 mega electron volts. So that's going to be the energy of that gamma ray.